So if we look at each box within the periodic table, we're going to see that first of all, there is a symbol that represents each element. This symbol represents helium, okay? On top of the atomic symbol, you're going to see an atomic number, okay? That number, like the definition says, tells you how many protons and electrons each element contains. If you look at each individual element on the periodic table, you're going to see that each individual element has its own unique atomic number. Okay, the atomic number, once again, tells you how many protons and how many electrons each element contains. Once again, I want to emphasize that every element that's on the periodic table is unique because it has its own unique set of protons within the nucleus and its own unique set of electrons in the orbital. The protons and the electrons are always going to be in equal numbers. So if I have in hydrogen 1 proton, I'm going to have 1 electron in the orbital. A second ago we saw 92 protons within the uranium atom, okay, in the nucleus, and 92 electrons in the orbital. There's always the same amount of protons and electrons in elements. Okay, what I want you to do now is go ahead and write down chemical bond and write down the definition. Go ahead and press pause if you need to. Okay, let's take a look at this image. So in this image, okay, I see that there is 2 atoms, okay? Here I have 1 proton and here I have 1 electron, okay? This is the nucleus and the outer part is the orbital, okay? I know that these atoms are hydrogen atoms. Why? Because it has 1 proton and 1 electron. If I look at the periodic table and I look at the box for hydrogen, okay, I'm going to see that the atomic number is 1 for hydrogen, okay? Now, when these 2 atoms, okay, they get close in proximity, okay, their orbitals are going to overlap, okay, and they're going to share electrons. They make a strong connection, which is called the chemical bond. This is a very important concept for you to note. If you have any questions about this concept, make sure you let me know. I want you to understand this. So now we're going to talk about a molecule. Okay, a molecule is when at least 2 atoms are chemically bonded together. Go ahead and write down the word and the definition. And I will explain it once you're done. If you need to, press pause and then play once you're done. So I'm going to use this image here to represent or to talk about a molecule. Okay, these 2 atoms individually, they're atoms. But once they become connected, they make 1 molecule. Okay, so this is a molecule. If you break this bond, if they're not sharing electrons, they become individual atoms. Okay, atoms have to be connected like this in order to be a molecule. Minimum, you must have 2 atoms bonded or connected in order for it to be a molecule. Okay, molecules can have a huge number of atoms, but minimum they must have 2. There's molecules that have 1 million, 1 billion, 1 trillion number of atoms, but minimum they must have 2. Okay, 1 atom by itself does not make a molecule. Okay, they're atoms. Let's go ahead and talk now about what a compound is. Go ahead and write down the word compound and write down the definition. Okay, a compound is when you have at least two different elements bonded together. An example is H2O, water. A non-example is H2. So let's take a look at this image here, okay? First of all, I want you to tell me how many elements there is in this image right here, okay? There's actually two elements. There's oxygen and there's hydrogen. Okay, if someone said three, okay, you told me how many atoms there is. Yes, there is three atoms. 1, 2, 3. But there's only two elements, hydrogen and oxygen. In order to have a compound, you must have two elements. Let me show you a non-example of a compound. By the way, guys, these lines that you see here in between hydrogen and oxygen, they represent a chemical bond. Okay, there's two electrons being shared there. Okay, anytime you see an image that has a line like that, those are two electrons that are there. So let me go ahead and show you now a non-example of a compound. Okay, I'm gonna try drawing here and see how it comes out for me. Okay, guys, not the best drawing in the world, but it works. Alright, so here I have one hydrogen atom, here I have another hydrogen atom. Okay, how many elements do I have here? If you said 1, you're correct. Okay, I only have hydrogen. I do have two atoms. Okay, now this is not a compound because I only have one element. Yes, it does have two atoms. It is a molecule, but it's not a compound. So this is a non-example of a compound. Okay, go ahead and write down the next word, chemical reaction. What I want you to do is I want you to write down all this right here. Okay? In the image, the only thing that I want you to draw in your notes, I'm going to go ahead and circle it, is this. Okay? Alright, so if you look at this chemical reaction, okay? By the way, A connected to B plus C connected to D means that there's two individual molecules there. The arrow means yield, okay? And A connected to C plus B connected to D is what's happening at the end of the chemical reaction. This is the beginning, okay? And the end is over here, okay? We call this part of the reaction, these are the reactants, okay? And these are the products, all right? And the plus sign means that it's a separation of two individual molecules. Okay, so take a look at A. It's connected to B. What's going to happen in this chemical reaction? A is going to break its bond. Okay, A connected to B is like a couple, and they're going to break up. All right, and what's going to happen is A is going to make a new bond with C. Okay, so if you look over here on this side, at the end of the chemical reaction, A is now bonded to C, whereas in the reactants it was connected to B. Now where did B go? Well, B is over here now on this side. Now B is connected to D. Okay? So all that happens during a chemical reaction is in the beginning you have molecules that break their bonds. Okay? The atoms, they rearrange and they make new bonds, new connections. Okay? And these new molecules that are being made, okay, they have their own unique properties, physical properties and chemical properties. Guys, this concludes the presentation. If you have any questions whatsoever about what you saw today, feel free to ask me whenever you have time. I'm available in the evenings and during lunchtime or at the end of class. You can always ask me a question if you have any questions. Bye guys, take care.